Number 14 wants us to determine whether this infinite geometric series converges or diverges, and if it does converge, then find the sum. So for us, what we're going to do is, here are these blue, is we have to get the ratio here. So I'm going to take 30 and divide it by 150. All right. Cancel that, and I'm going to get a ratio of 1/5. Now, because my ratio is between 0 and 1, this implies that it's going to it's going to converge, sorry. That means it's going to converge. Okay? Because if I'm between 0 and 1, then I can actually add this geometric sequence, or this geometric series up. So the formula is very, very simple. The sum to infinity for an infinite geometric series whose r is between 0 and 1 is nothing more than the very first term over 1 minus the ratio. Well, that's going to give me the very first term is 150 all over 1 minus the ratio, which is 1/5, right? So you can just plug that part into your calculator if you really want to. So there you go, we get 150, and you divide that by the quantity of 1 minus, parentheses, 1 divided by 5. And then close that set of parentheses there. And you get an answer of 187.5, or if you want to convert that to a fraction, you can do that too. And you get 375 over 2. So put that away. So 375 over 2. I think that's the answer I put in the review for you. So pretty straightforward. You just have to make sure that your r is between 0 and 1. Now for this one, for part B, right, if I took negative 20 and I divided it by negative 10, that would give me a value of 2, right? The second term divided by the first term. And 2, since, this is what we need in order for this thing to converge, 2 is outside of our converging area here. So therefore, this whole sequence is going to diverge, and we are not able to find the sum of that because it just goes on too big. So there you go. So part A does, and you get 375 over 2. Part B does not.